Currently, we're looking at the analysis of one categorical variable. In this particular lecture, we're going to discuss the idea of sampling distributions, and specifically the sampling distribution of p hat. We've talked about in past lectures how a sample value, or a measurement referring to a sample called a statistic, would vary from sample to sample. So we wouldn't expect measurements coming from a sample out of a population would have the same value. We would expect that that statistic would be different from different samples. Therefore, we're indicating that we have some measurement of variability that we have to account for. So the idea behind a sampling distribution is you would start with a population. And remember, when we have measurements referring to a population, we have a measurement called, right now, P. So P is a population proportion. It's our parameter of interest for this chapter, looking at the analysis of one categorical variable. So we're interested in P, and ultimately when we make a statistical inference, we want to estimate or make an inference on P. So P is the parameter of interest, and it's a value coming from the population. Now what we'll end up doing is taking a sample out of the population. And when we take a sample, we would get a value called p hat. So that's our statistic. It's the measurement that's connected to our sample, and it's coming from, this sample is coming from a larger group or a population. Now, I could take a sample of size 4, and you could then take a sample of size 4, and you might get an entirely different group of people, and therefore a different value of p hat. Now, it's still p hat because it's a measurement coming from a sample, but it's a different sample, and therefore a different value of p hat. Now, conceivably, you could continue to take multiple random samples of the exact same size from the exact same population and keep getting different values for p hat. So here's a third example. We could do it again, and I would have an entirely new sample and therefore a new value of p hat. So it's still p hat because it's from a sample. It's just different because I now have a different group of people. So because I end up with, if I were to take every conceivable random sample of here size 4 from the same population, I would actually end up with a whole new population. It's just kind of an odd population. It's a population of values of p hat. Now whenever you describe a sampling distribution, which is what this ends up being, so because it's a population of values of p hat, all of these measurements are referred to as the sampling distribution. Here specifically, it's going to be the sampling distribution of p hat. Now when you're interested in a sampling distribution, there are 3 pieces of information that you're interested in. First, you're interested in the mean. So where do all of those p hat values, if you were to put them on a graph, where do they center themselves? So what is the mean? The next thing you're interested in is something that's referred to as standard deviation. So it helps you to measure how much variability or spread there is amongst your statistic, and here our statistic is p hat. And then the third thing that you're interested in when you're thinking about a sampling distribution is the shape. Now after a lot of effort, we know that the mean of the sampling distribution of p hat actually will center itself or be equal to p. So remember, p is our parameter of interest, and we know that all of those p hat values, if we were to put them on a graph, would center themselves around our parameter of interest, or p. The next thing for standard deviation, and to give you some background on standard deviation, it can never be negative because it's a measurement of spread, and it also is a measurement of how much variability. So the larger the standard deviation, the more variability. Now the formula for standard deviation, when you're thinking about it in terms of the sampling distribution of p hat, you would have p times 1 minus p, and you would divide that product by n, and then take the square root of that quotient. So you can see that as n increases, because it's in the denominator, we would expect the value for standard deviation to decrease. And then the last thing, in terms of shape for the sampling distribution of p hat, we would expect this to be normal. And it will be normal if 2 things are true. You have to have both n times p and n times 1 minus p greater than or equal to 10. If both of those two things are true, then you will have a distribution that is normal. And we'll describe what normal is in further lecture videos. So right now, realize we're talking about the sampling distribution of p hat, and there is a sampling distribution because p hat values would vary from sample to sample. And if you're interested in that sampling distribution, there's 3 pieces of information you want. The mean, or where they center themselves, standard deviation, so how you measure variability or spread, and then finally the shape, which we know will be normal if both n times p and n times 1 minus p are greater than or equal to 10.